Today we're talking about the mean value theorem. And when you think of the word mean in math, it means the average. So when we're talking about mean value theorem, there's going to be an average rate of change in there. So this theorem is the third now formula or theorem that you do have to cite on the AP exam. So we've talked about intermediate value theorem, the extreme value theorem, and now the mean value theorem. So the mean value theorem says if our function is continuous at every point and it has a closed interval, so it starts just like extreme value theorem, but the one extra part is that it's differentiable on the open interval from A to B. Okay, well, they don't include the endpoints when they talk about differentiability. Then there's at least one point on that interval where f prime of c, or the instantaneous rate of change, is equal to f of b minus f of a over b minus a, or the average rate of change. So we're going to write that little note to ourselves. F prime of c is our instantaneous rate of change. And then this one is our average rate of change. That's our algebra 1. So notice that I wrote it out this way. If I multiply by this b minus a over to this other side, you get f of b minus f of a equals f prime times b minus a. I want you to notice that that looks just like y minus y1 equals the slope times x minus x1. We're talking about using that instantaneous equaling our average rate of change. So it looks just like our point slope formula. So the mean value theorem is an existence theorem. It tells us that this number exists, but it doesn't necessarily tell us how to find it. So in example 1, it says, show that the function y equals x squared satisfies the hypotheses of the mean value theorem. There were 3 of them. And in fact, I would even take a highlighter and highlight all 3 of them. It had to be continuous, had to have a closed interval, and it had to be differentiable. So we have to show that it satisfies those 3 conditions from 0 to 2, and then we're going to find the solution where the instantaneous equals the average on that interval. So first thing we need to check is that it is continuous, and in fact x squared is always continuous, so that's good. Do we have a closed interval? And they told us to go from 0 to 2, so check. And is it differentiable? And it is differentiable. X squared, derivative is 2x. All right, so in order to do this, f prime of c, well, we know f prime of x is 2x, so that means f prime of c, we're just going to plug in c for x, would be 2c. The other part of this formula is f of b minus f of a all over b minus a. That means I need 2 ordered pairs, and they told us to start at 0 and end at 2. So if I plug in 0 to my equation, we get 0. And when I plug in 2 to this equation, I get 4. So we get 4 minus 0 over 2 minus 0, or a slope of 2. So they want to know, where does the instantaneous rate of change equal the average rate of change? So we would say instantaneous equals average. Where does slope equal slope? Divide by 2. And we find that it happens at 1. So in example 2, I want you to investigate each one of these. We'll do A first. Where does this one not work for mean value theorem? Which condition does it fail to satisfy? So take a moment and look at this one. So we've seen this before, square root of x squared. Remember, it's plus or minus x, which is the same thing as absolute value of x plus 1. And we know absolute value of x has a corner at x equals 0. So that means this one can't be differentiable from -1 to 1 because there's a corner at 0. So this one did not work because it's not differentiable at that point at x equals 0. All right, now I want you to investigate this one. I'm telling you mean value theorem does not work. You need to tell me why. So when I look at this one, if I plug in 1 up here, I get 4, and when I plug in 1 down here, I get 2. So that means that this function's not continuous at x equals 1. And according to the mean value theorem, it has to be continuous on the entire closed interval, which means it can't be continuous on the closed interval. It's not going to work at x equals 1. So that was the condition of the mean value theorem that did not work. So our next one, example 3, gives us this function, square root of 1 minus x squared, and they tell us to start at a and of -1 and b is 1. And they want us to find the tangent to f from -1 to 1 that's parallel to the secant AB. Parallel just means same slope. We've seen this many times before. And so when we're talking about a tangent being parallel to a secant, that's exactly what mean value is saying. Here's our tangent, here's our secant. We're trying to show that mean value theorem works. So first thing we need to know is the two ordered pairs. So A is at -1 comma f of -1. So if I plug in -1, I get 1 minus 1, square root of that is 0. And B, if I plug in 1, I get 1 minus 1, square root of that is 0. So the average rate of change is the really easy one. So my secant of AB, I'm going to put secant, is 0 minus 0 over 1 minus -1. So my secant line has a slope of 0. So the harder part is finding the tangent line. So this one is a chain rule. So if I'm going to find the slope of the tangent line, I have to use the chain rule. So u is 1 minus x squared. And my outside function is square root of u. So the derivative, I get -2x. And this one I get 1 over 2 square roots of u. We've done this one enough times. It's 1/2 u to the -1/2. And I'm just simplifying that. So when I put these together, I get that f prime of x is equal to -2x over 2 square roots of 1 minus x squared. And I can cancel those 2's. So now the question is asking, when are these two slopes the same, parallel? So I want to know, when does -x over the square root of 1 minus x squared equal 0? Sorry, you get a nice zoomed in look. So to solve this one, I'm just going to multiply by this bottom piece, which gives me 0. So I end up getting -x equals 0, which divide by -1, you get x equals 0. So this one has a tangent line parallel to its secant line at x equals 0.